Hello, in this recording we're going to talk about special right triangle relationships, and the two that we're going to look at are the 30-60-90 triangle ratios and the 45-45-90 ratios. I'm not going to explain in this recording where these come from. We're just going to say they exist, and here's what you put in your notes. So for a 30, 60, 90 triangle, there's a 30-degree angle, a 60-degree angle, and a 90-degree angle. We only need to know two of those angles in order to know that that's what we're dealing with. And in that case, the short leg is going to be half the length of the long leg, or the long leg will be, the hypotenuse. The hypotenuse will be double the short leg, and the long leg will be the same as the short leg times the square root of 3, which is an irrational number, so it's a little bit hard to deal with, but that's what it is. And the second ratio we'll look at, 45-45-90, the two angles that are not right angles are each 45 degrees, so this is an isosceles triangle, which means that the two legs are congruent, they're both the same length, and the hypotenuse is that same length times the square root of 2. Again, another irrational number. This is most useful because the 45-45-90 triangle is half of a square, so that x square root 2 describes the diagonals of a square. Okay, let's do an example here, and I've kind of mixed them up in just random order, some of my examples going from easier to harder. And the idea that I'm going with here is that we maybe don't know which one we're dealing with, and we need to figure out how do you identify this. So here we go, number 1. We have a question where there's a triangle. It's a right triangle, and there is an angle in that right triangle that is 30 degrees. And if I know two angles in a right triangle, I know the third angle because they have to all three together add to 180. So that third angle has to be 60 degrees. And I could do the math if I wanted to verify, but you can see that that's all I needed to know that this is a 30-60-90 triangle. And once I've identified that, then I come in and I say, okay, 30-60-90 triangle, the side across from the 30-degree angle is going to be my x. And the side across from the right angle, the 90-degree angle, is going to be 2x. And the side across from the 60-degree angle is, the long leg is going to be my x square root 3. And so we can see here that x is on the side with the length that we know, which is 6. So now I can fill in the rest of the sides. The hypotenuse is double that, so it's going to be 12. And then the long leg is going to be that short leg, 6, times the square root of 3. And if I wanted to, I could type the square root of 3 times 6 in my calculator and get the answer in a decimal form. I won't do that here for the recording, but it tends to be what we're doing here. So step number 1, we identified two angles in the triangle. We have to be given two angles in the triangle. And one will be 90 degrees and one will be either 60 or 30. I suppose it's possible that they give us the 30 and the 60 and they don't tell us the third one is 90, but in any case we need to know two angles so we can identify this as a 30-60-90 triangle, and then we need to know one side, and then we can figure out the other two sides from that. Let's do that again here with our second example. This time we have an angle that is 60 degrees and one that's 90 degrees. So therefore the other angle must be 30 degrees. And this time we know the hypotenuse, the long side, is 8. And we know that that side is double the short leg, the shortest side, the short leg. So that means that the short leg is half of 8, which is 4. And then the other leg must be 4 square root 3. And so those are so we know three things about the triangle to start with: one side and two angles, and then we can figure out or tell three other things that weren't given to us at the time. Okay, let's do an example with the 45, 45, 90. We've got a right triangle here with one angle that's 45 degrees. We do the math and find out the other angle is also 45. Actually, we don't have to do the math because it's not possible for a triangle to have one 90-degree angle, one 45, and the third angle be anything but 45. One of the legs is 7. That means that the other leg is also 7. The two legs in a 45, 45, 90 triangle are congruent. And the hypotenuse must be the 7 square root 2. And that's, again, from the formula. We don't have to do any calculation here. Okay. Now, let's do some of the hard ones. Going back to the 30, 60, 90 triangle here, we've got a right angle. We have a 30-degree angle, so that one has to be 60 degrees. And we don't know what the short side is. We don't know what the long side is, the hypotenuse. All we know is the third side. I always call it the third side, the side that is the tricky one. That is the x square root 3 side. So I know that that is equal to 6, so what are the other two sides? So we have to do some algebra here. The x square root 3 side is 6. What is x without the times square root 3? Well, we're going to divide by the square root of 3. And we find out that x is 6 divided by the square root of 3. So x equals 6 over the square root of 3. And we do not want to keep our answer in this form. If we're using a calculator and we just want a decimal answer, you could just type 6 divided by the square root of 3 in it, and you'll be fine. But the calculator can handle that. But most of the time when we're dealing with these special right triangles, we don't want our answer in decimal form. We want it in simplified square root form. So I'm going to multiply the fraction here, 6 over the square root of 3, on the top and the bottom by the square root of 3. And I get 6 square root 3 on top. The square root of 3 times the square root of 3 is the square root of 3 squared, which is 3. And then 6 square root 3 divided by 3 is 2 square root 3. So there is what x equals. X is 2 square root 3. And if x is 2 square root 3, then double that would be 4 square root 3. And there's my two answers. So notice that you cannot get away from irrational numbers in these. So it could be that the two sides, the short leg and the hypotenuse, are nice easy numbers, but then the long leg, the third side, is the square root of 3. But if that one is a nice easy number like 6 here, then it's the other two that are going to be complicated. So there's no way to avoid irrational numbers, so you might as well just deal with them. Let's do one more example. This time we've got a 45 and a 90-degree angle. This must be a 45, 45, 90 triangle. The ratio is going to be x, x, x square root 2. And you can see that the side we know is the x square root 2 side. So x square root 2 equals 5. We'll divide by the square root of 2 on both sides. And x equals whatever 5 divided by the square root of 2 is. Again, we can do it on the calculator, but that's not the standard way to do this problem. Instead, we'll multiply the top, the numerator, and the denominator by the square root of 2. We're going to rationalize the denominator, so we're just going to do square root of 2 times the square root of 2 is 2. and then the numerator becomes 5 square root 2. This time we can't simplify that. 5 square root 2 over 2 can't be reduced or anything, and so that is my final answer for x. 5 square root 2 over 2. And again, you can type that on your calculator if you want to get the decimal answer, but that's not the preferred form. The preferred form is in exact answer, or so if you type it in the calculator, you would get a rounded answer, and we often don't like that. Okay, let me slide over here and show you another problem. This is a kind of a popular, tricky math problem where we have a big triangle here that's made up of two small triangles, and I've made it explicit here. One is 30, one is 45. And sometimes they will give you this line, this altitude line here, and sometimes you'll have to draw it yourself. That forms a 90-degree angle, which cuts this big triangle into two small triangles. And you can see that one of the angles here is going to be 60 degrees, and one is going to be 45 degrees. So that now we have a 30, 60, 90 triangle and a 45, 45, 90 triangle. And we only know one side out of this whole thing. So that side is 12. It happens to be the hypotenuse of the 30, 60, 90 triangle. So that means that the short leg is half of 12, which is 6. And the other side, from here to here, is 6 square root 3. Okay, now on the 45, 45, 90 triangle, that triangle has got one leg, one of the congruent sides is the same as that short side of the 30, 60, 90 triangle, that's 6. And so the other leg, even though I didn't draw it very well here, is also 6. And the hypotenuse is 6 square root 2. Okay, so and one of the big popular answers then is this entire distance is 6 plus 6 square root 3. Notice that we can't combine those together, we can't add that together unless we turn it into decimal form and estimated decimal form. So there is our answer for all the possible questions that we could have been asked about this. Thank you for watching. Make sure you put the special right triangle ratios in your notes. They show up all over the place. Have a great day.